In topic 4 of chapter 3, we're continuing with graphing and parts of the equations we've been studying. We're going to take a look now at the slope of a line. So when we think of slope, we often think of some kind of ramp that's steep or not too steep, or the road that's hilly, and even if you're a skier, you have used the word slope. Okay, so these are the objectives that we're going to be covering, and we'll jump right into it. Now, when we measure slope, we're actually measuring what is called the steepness, and that is a ratio. And let's give you the full treatment here. So the letter we use for slope is M, and this is a ratio of y units in our graph over x units. And this is sometimes referred to as rise over run. So this is vertical and this is horizontal. So if we look at a graph such as this, and we see that there is a ordered pair right there and an ordered pair right there, and if we could, and these are right on the grid points, we could just make a little triangle and say, well, how many units are there? There's 2. So those would be our y units. And how many units are here? 1, 2, 3, 4. It rises 4. So our ratio of y units over x units, rise over run, is 4 over 2. That simplifies to 2, in a sense, over 1. Now we don't usually write the 1, but when we're thinking of slope, it may be a good idea to put the 1 there. Now, going to the right here was positive, and going upward is positive. Now how about if we did it this way? We started here and went down. That would be negative 4 units. And then we went to the left. That would be negative 2 units. So negative divided by a negative gives you a positive, so it still ends up being this. Now if we made a smaller triangle here, we could have gone over 1 unit and up 2 units too. So wherever you go, in fact, if you went all the way over here, all the way up here, it would be this same ratio. So for every unit of run, you get 2 units of rise. Or for every 2 units of run, you get 4 units of rise. That is your basic ratio of slope. Now this brings us then to our formula, which we're calling formula 3, which is the slope formula. Now if we have an ordered pair that we're calling the sub 1s, and another ordered pair that we're calling the sub 2s, it would go in the formula that y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is your formula for slope. Now, let's look at some examples. So in example 1, they're giving us an ordered pair and another ordered pair. Now we designate one as the sub 1s and the other as the sub 2s. So y sub 2 will be a 5 here. Now minus is in the formula, and x, or I should say y sub 1 is 3. Then we take our x sub 2, which is 2, minus 0. So 5 minus 3 is 2, and 2 minus 0 is 2. So our ratio then is 1 over 1, or just plain 1. Now this is positive, and if we plotted these points, we'd get a line there and a line there. And we will find that, generally speaking, if our slope as we move from left to right is upward, this is going to be positive slope. Our slope will be positive. So in this case, again, we're using the formula. We'll designate this as the sub 1s. This is the sub 2s. So y sub 2 minus y sub 1, x sub 2 minus x sub 1. So this will end up being a negative 1 over negative 8. And it's important that we copy it correctly. This was a negative 4 here. So when I put a negative 4 into this formula, it's the opposite of a negative 4. This should be a positive. So I get a positive now 7/8. Now it's a positive 7 over a negative 8. And generally we put the sign, if it's negative, by this division bar. So that gives you 7/8. So this slope is negative. And we find when we graph that, if it starts high as you move from left to right and goes down, this is negative slope. So if we started here and went down 1, 2, 3, 4, 5, 6, 7, this is a negative 7 going downwards, and then going over this way there would be 8 units. So again, from your points you could physically count the units and develop your slope. That's what slope is, the slant of a line. If it starts high and goes down, it's negative slope. If it starts low and goes up, that's positive slope. Now, as we've been saying, if it's in this slope-intercept form, which we're calling equation 2, that whatever is in this m position, that is the coefficient of x, when you solve the equation for y, this is the slope. And we said b was our y-intercept. We put a little hyphen there. So if we have an equation that looks like this, our slope is the coefficient of x when it's solved for y, 2/3, and our y-intercept is 4. Now remember, the way to write that, if they ask, often is 0 comma b, So that would be 0, 4. Anytime you see it like this, this is the y-intercept. So looking at the practice, we see in function formation, again, whatever is with the x, a -4, remember that's over 1, but we can just say -4 is our slope, and our y-intercept is 6. And they're talking now about the slope-intercept form. Okay, we anticipated a little bit. Now, when we look at example 4, what form is this equation in? Well, here it's in standard form. So if we want to find what our slope is when it's in standard form, the rule in general is solve for the letter y. And you want a positive y, so I'll just bring it over. Transpose this 4 to this side, and then I get 3x. Stays there. Now I divide each term by 4, and then I can write it in its usual form. Y equals, because these cancel out, 3/4 x minus 1. So now my slope is 3/4, and my y-intercept is -1. And again, we often write the -1 this way. All right, let's do this one too. 2x minus 3y equals 9. Bring this over, 3y, so now it's positive. Bring the 9 over as a negative. And now we're going to divide each term by 3. And I can write it this way now. Y equals 2/3 x minus 3. So our y-intercept is -3, and our slope is 2/3. Okay. Now, one of the things they ask is to interpret what the slope-intercept form means. So, let's read this over to ourselves and then comment on it. So, this is the equation in function form that approximates the price of tickets, a day-long ticket entry into Disney World. And it's starting in the year 2000. So what does this mean? Well, this is going to be your time in years, and this is $3.32. So with 1 year, this would just be this and this. That would have been the price in the year 2000. But in 2001, this x is going to be 2. So 2 times this added to that, and so on and so forth. So in 10 years' time, in the year 2010, this x would be 10. So this would be added after you multiply it by 10 to this, and that would be the price. So again, understanding this was what it costs that first 0 year in a sense, and then after 1 year you would add this to it. And there is a graph of it. Now notice it didn't quite exactly follow the blue line, but the blue line averages what we're seeing, because this other dotted line is not linear exactly. It's somewhat linear. Okay. So we're now going to apply this, predicting future prices. You understand what the equation means. What would be the price in 2015? Well, you're going to put 15 for the X, that is, since the year 2000. Multiply that by $3.32 and add it to that. And the price in 2015 should be about $93.90. Okay? Now, what does the slope of the equation mean, which is $3.32? That's the amount it's going to increase each year. And the X was the number of years, and the $44.10 was the initial price in the year 2000. Okay. In a sense, that's your y-intercept there. And all of this is in your book as well. Now, objective 4 is to find the slope of horizontal and vertical lines. Well, here, this is a vertical line, x equals a. It looks like this. If we put 2 points into our slope formula, interestingly, it comes out 4 divided by 0. Now, in mathematics, we said we don't define anything divided by 0. But that's what the slope is coming out as. So what do we say the slope is? Anytime we have a vertical line, we don't say 4 divided by 0. We say the slope is undefined. So from now on, anytime you see this formula, a or x equals a, the slope is going to be undefined. So put a little note, and in fact on our little sheet there's a place to put that. The slope of vertical lines is undefined. Now when we look at the slope of the general formula, y equals b, in this case y equals 2, we know it's a horizontal line going through the y-intercept at 2. Again, if we put 2 points into our formula, we get that the slope is equal to 0 divided by some number other than 0. Now, what students have done in the past sometimes is they've put, what is the slope? And they'll say the slope is 0 divided by 1. Well, that math lab will count that wrong, because what is 0 divided by any number other than a 0? And the answer is it's 0. So from now on, the slope of any horizontal line that has this equation is 0, and not 0 over 1 or 0 over 5. The answer is 0. So now a couple of review items that would go into your notes very well. The slope of any vertical line is undefined. the slope of any horizontal line is 0. And here's a little summation of some general characteristics of slope. So when we see a line that starts low and goes up, this is positive slope. A line that starts high and goes down, this is negative slope. A horizontal line is 0 slope. A vertical line, undefined. Now as we look at slope on a graph, and let's raise it up just a little bit to see this better. Slopes that are steeper, this is a 5. Slopes that are less steep, this is 1/2. So it gives you sort of an idea. Now formulas 7 and 8 on that sheet is where we compare slopes of parallel and perpendicular lines. Now lines that are parallel, as you can see here, have the same slope but would have different y-intercepts. And lines that are perpendicular, that is, they form a right angle. An interesting thing, when you multiply their slopes, you end up with a -1. So let's just quickly review the rules for this. And hint number 7 is if the slopes of one equation is equal to the slope of another, but the y-intercepts are not equal, then the lines are parallel. This is the symbol for that. And then for number 8 we say, if you take the slope of one and multiply it by the slope of the other, and the product of that multiplication is a -1, such as if you have 1/2 or 1/4 times a -4/1. Here everything cancels out, but you're left with a -1. Then the lines are perpendicular. So this is a little summary, and you should have that in your notes and on that review. So for example 8, what is the strategy of determining whether these lines are parallel, perpendicular, or neither? And the answer is you need to compare the slopes. Now, both of these examples in A are in standard form. So what you would do is solve for the slope. 7y, solve for y, is a -3x plus 4. So I'm taking my 3x term, transposing it, change its sign. Now I'm going to divide everything by 7 now. So I get y equals a -3/7x plus 4/7. Now I solve this equation for y. I have 14y, transpose the 6x, it's a -6x plus 7. Divide everything by 14. And I get now y equals, I'm going to simplify this, a -3/7x, reducing that, plus 7/14. And now what I do is I compare my slopes. And my slopes are the same, but my y-intercepts are different. So the lines are parallel. And this is the proof of it. This is what I want to see on your blue sheets as you take your test on this. And this works supporting this type of problem in your quiz-mes in practice. Now here we want to again solve for the letter y. So let's just do it here. 3y equals, I'm going to transpose this, becomes a positive x plus 2. Now divide everything by 3. And I get y equals 1/3 x plus 2/3. Now I'm going to solve for this one here. 6y, transpose this, equals a negative 2x plus 5. Now divide everything by 6. This is y equals a negative 1/3, I'm going to simplify, plus 5/6. I now compare my slopes. This is a negative 1/3, and this is a positive 1/3. Now if you multiply these, you get a negative 1/9. Is that a negative 1? No. So this one is a neither. Now this one's a little tricky because you say, well, wait a minute, they're the same slope. No, one's positive and one's negative, so they're not the same. Here the slopes were both negative and the same. Okay, so if you were to graph letter B, now the lines, one's positive and one's negative, but they're not perpendicular. That's why it's neither. Okay, I believe this wraps it up. We have some graphic things that we don't use, and there it starts the section review.